Okay, what we're going to do is generate a grid. Each of the spacing is 0.1, and we're going to add a curve. We start from the right hand side, come over to about a little bit short of about 3 units, and then 6 units down, 6 units across, and 6 units up, and all the way to the left. Then we're going to add a fillet, change the curve type to fillet. Between those two curves we'll have a radius of 0.1. Between those two curves we'll have a radius of 0.1. And now change to a circle. It'll be via center and a point. We'll locate the center just above up to radius 1 and add an element that falls a little bit short 1 unit of the table and fills in between the punch and the table. We're now going to change some settings on the elements so we see them all and turn on the nodes. Subdivide the elements into divisions of 30 by 3 by 1. Pick the elements, all existing, and there's our mesh. We're going to sweep all the nodes. Any coincident nodes will be merged together and renumber everything. Turn off the grid and do material properties. For material properties we'll use Young's modulus of 30 million and Poisson's ratio 0.3, and we're going to make a table for the work hardening. Table type is equivalent plastic strain. There we go. And we're going to enter an equation via a formula, which is 50,000 times the quantity 1 plus x to the power 0.6. And we'll fill the curve and fit it. And then adjust the minimum so it's 0, and now we can see that it starts at 50,000 and goes up to 100. We'll do another table. This will be a time table. That's the x-axis. And now we'll add some points for the y-axis. 0, 0, 1, minus 1, 2, 0. And do a fit. And all we want is just a ramp down and ramp up. We'll go back to the model. We'll add the table to the equivalent stress. The magnifier is 1. The table is table 1. Add all existing elements to this material. And now define some boundary conditions. We'll fix the displacements. Nope, I guess we're going to do contact. We're going to add a deformable contact, which are all the elements. That's our first body. The second body, which is new, will be rigid, and it will consist of the circle. And we will specify its position by one of the tables, the ramp table. So we'll give this a value of 0.3 and then use the table to ramp the punch down and then up, just like the table. Oh, and we've got another body to add. It's a rigid body, but it'll include all of the entities at the bottom. And that's about it. Now we'll do the boundary conditions. Fixed displacement, x is 0, in all those nodes right there. And we're done with the boundary conditions. We'll do some load cases, be simple, static analysis. We'll specify force tolerance of 1%. And then we'll just copy this table, make another one. But this time we'll check on residuals and or displacements. Then do jobs. We'll pick those two load cases. And then go to analysis, indicate its large strain. We'll do some post results, equivalent von Mises stress and total equivalent plastic strain. And of course the analysis dimension is plane strain. And now we're ready to submit the job. So we go to run, submit. And we notice the job's running, producing results and as we're watching it, and it's completed. We'll save the model, open the post file, turn off the nodes and just do the outline of the mesh, contours, equivalent plastic strain, deform shape, and monitor through the results. And we're just about done with that. We're also going to monitor the force displacement relation. And just go into presets under history plot, and we see the force